Hello once again, welcome to my class. My name is Teacher Hura and today is another day for calculating the mole. In this video, I'm going to show you about the molecular formula. The molecular formula of a compound shows the actual number of each kind of atoms present in a molecule of that compound. It is very closely related to the empirical formula. So if you haven't checked out my videos on empirical formula, I'd suggest first you go and check them out to see how to calculate the empirical formula because it is the precursor for calculating the molecular formula. So now let's get straight ahead. Now the formula that you're going to use or the mathematical expression that you're going to use in these questions is this one here, whereby the mass of the empirical formula that you've calculated multiplied by a value n, we can give it an abbreviation of n, gives us the relative molecular mass. And this letter n right here is always a whole number. So in case you calculate using this expression and you find that you have a decimal, you need to round it off to the nearest whole number. So in brief, we can have it like this. We can say that n is given by the relative molecular mass, RMM, divided by the mass of the empirical formula. So this little formula down here is the one that is going to be very critical in answering questions on molecular formula. So let's get to the first question. So in this question, you're told that a compound of carbon, hydrogen, and oxygen contains 26.7 grams of carbon, 2.2 grams of hydrogen, and 71.1 grams of oxygen. Calculate its molecular formula if its relative molecular mass is 90. And right here, you've been given the relative atomic masses of each of the elements. So just like you remember we did in the empirical formula videos, we'll start off with the elements present in that compound. And in this case, we have carbon, hydrogen, and oxygen. So the first one is carbon, hydrogen, and oxygen. The next is to determine the mass of each of these elements. So the mass. So for carbon, it is 26.7. This one is 2.2, and this one is 71.1. The next part is to determine the relative atomic mass of each of these elements, and that is given in brackets right here. The next is to calculate the moles. As usual, you know already, this is my favorite part. It is usually determined by taking the mass and then you divide the relative atomic mass, which is RAM. So this one is going to be, now here you just punch this in a calculator and you end up with 2.2. And here, and finally, that one gives us 4.4. So you can see now we have our moles. The next thing is to calculate the mole ratio. The mole ratio is determined by dividing all these mole values by the smallest one. So if you check these, you'll find that 2.2 is the smallest one. So you divide every mole value with the smallest one. Oh, sorry. This is a 2.2. So right there, the next part is to calculate the empirical formula, which is now going to be given by the number of carbon, hydrogen, and oxygen. So our empirical formula is going to be CH O, and 2. So this becomes our empirical formula. Now, taking you back to our little formula here for calculating the relative atomic mass and the molecular formula, you'll find that we need to calculate the mass of the empirical formula, multiply it by n, that gives us the relative molecular mass. Now, in this question, you'll see that the relative molecular mass is given here as 90. So now we need to calculate the mass of the empirical formula. So here we'll calculate it like this. So the mass of the empirical formula is the mass of carbon, which is right here, 12, plus the mass of hydrogen, which is 1, plus the mass of oxygen by 2, which is going to be a 16 by 2, which is 32. So all this needs to be multiplied by n, and then should give us the relative molecular mass, which is 90. So you find out the value of n. So this one here, you calculate the total is going to be 45. N is equal to 90. Therefore, n is equal to 90 over 45, which gives us 2. Now that you have calculated the value of n, we need to multiply each of these elements in the empirical formula by 2. So that goes like this. So the C, the carbons now, they're supposed to be 2 of them. So you multiply by 2, you have a C2. Then you go to hydrogen, you multiply that 1 hydrogen by 2, you have a H2. And finally, oxygen, there were 2 of them. Now you multiply by 2, you end up with a 4. So this one forms your molecular formula of that compound. So now let's head out to the next question, question number 2. So once again, we have a question that says an organic compound contains 9.1% of hydrogen, 54.6% of carbon, and the rest oxygen. If its relative molecular mass is 88, what is its molecular formula? So now here, once again, the procedure is exactly the same. But remember, we have been given percentages. And in my previous video, I showed you that these percentages could also mean the mass. If you say that if the compound was 100 grams, then it would be 9.1 grams of hydrogen or 54.6 grams of carbon. So remember, you can use that. So let's start off. The first thing is the element. The elements present in this compound are carbon, hydrogen, and oxygen. Then next, we check the mass. We said that these percentages, we assume that the entire compound is 100 grams. So that means we'll have 54.6 grams of carbon, and we'll have 9.1 grams of hydrogen. Now, since you have assumed that it is 100, so now the mass of oxygen is going to be the rest. So you'll have to take 100, we subtract 54.6 plus 9.1. So when we calculate that, we end up with a 36.3. So that is the mass of oxygen. Then next, we move on and look for the relative atomic mass. So the relative atomic mass of carbon is given right here in the brackets. That one for hydrogen and that one for oxygen. So next now to my favorite part, calculating the mole, and you get it by calculating the mass over the relative atomic mass. So this one, when you calculate, you get a 4.55. 9.1 divided by 1 gives you a 9.1. 36.3 divided 16, This one, when you punch in your calculator, you end up with a 2.27. So now you can see we have already calculated our mole. The next part is to get the mole ratio, because we need the simplest whole number ratio. That's the first thing. So now mole ratio, we'll be getting this by dividing by the smallest value, and the smallest value this time is a 2.27. So right here we start with 4.55 divide 2.27, and this gives us a 2.0. 9.1 divide 2.27, this gives us 4.01, and of course 2.27 divide 2.27 is a 1. Now you can see we are not yet having whole number ratios, because this one right here is still a decimal over 0.01. But if you get such a value, all you need to do is to round it off to the nearest whole number. So that brings us to the combining ratio. Which is now going to be a 2, a 4, and a 1. So I've rounded it off this 4.01 to the nearest whole number. You can see it is very easy. Now next, we get the empirical formula, which is C2H4 and then an O. Now again, we get back to our formula. We said our formula that the empirical formula mass multiplied by an N gives us the relative molecular mass. Just to recap for you, remember this. So the mass of the empirical formula multiplied by N is the relative molecular mass. So now we need to calculate the mass of this. So we have 2 carbons and each of them is 12. So it's going to be 12 times 2. Then we add, each of hydrogen is 1 and there are 4 of them. 1 times 4. And then of course 1 oxygen, which is right here, 16. So now all this needs to be multiplied by a whole number N to give us the relative molecular mass, which is 88. So here we have 88, and then of course we calculate the total of this and divide. So when you calculate this, you end up with a 24 plus 4 plus 16, it gives us a total of 44. N is equal to 88. Therefore N is equal to 88 divide 44, which gives us a 2. That means that our empirical formula, each of these values down here, should be multiplied by 2 to get the molecular formula. So here our molecular formula is going to be the carbon, we multiply 2 by 2, gives us a 4. The hydrogen, we multiply 4 by 2, gives us an 8. And the oxygen, we multiply 1 by 2, gives us a 2. And that is our molecular formula. So you can see the calculation of molecular formula starts with the calculation of empirical formula. So it is very important to note that. And then now we add just a little formula that I added to you here, right? And this one here, the mass of empirical formula multiplied by N, which is a whole number, is equals to the relative molecular mass. Now, if you enjoyed this lesson, please give it a thumbs up and make sure you subscribe if this is your first time. And I always like to hear you. So make sure you make some little comments there. I'll always be giving it a heart, or maybe if you have any questions, you can always ask them right there in the comments. I'll be very keen to answer them.